This is lesson 12.3, analyzing geometric sequences. Today is January 31st. This is period 2. Alright, so with a geometric sequence, we are multiplying each term by a certain number to get the next term. So with arithmetic, which we've just finished, with arithmetic sequences, we added to get each new term. And with geometric, we are multiplying by the same number to get each next term. Alright. Tell whether the sequence is geometric. If it is, state the common ratio. I'll give you a second to write that down. Thank you. So, I just asked for a number that I can multiply each term with to get the next term, and I had a student that volunteered in problem number 3. We can multiply by -2 to get each new term. So the answer to problem 3 is yes, it is a geometric sequence, and the common ratio is -2.
Where does that R what?
R equals -2. So when we're finding a common ratio, we always denote it with the variable R. All right, problem number 1. Is there a number that you can multiply each term by to get the next term?
Yes.
What is that number?
3.
Okay.
What?
Let's expand on that idea. It's not exactly right, but we're thinking along the right lines. We're not multiplying by 3. We're doing what?
Divided.
Dividing by 3. Okay.
Definitely.
So now you have to answer me. To revise that answer, when I divide, I'm multiplying by the, what's the word? Division is the same thing as multiplying by the, no? Starts with R. Rectangle. Division is the same thing as multiplying by the reciprocal.
Oh, reciprocal.
You knew that. What's the reciprocal of 3?
What?
The reciprocal of 3.
Why he just whispered that in my ear?
So when we're taking a reciprocal, we're flipping the fraction upside down, right?
Oh,
Right?
Yeah. Yes,
So the reciprocal of 3 is 1/3. So if I multiply 81 by 1/3, if I take 1/3 of 81, I get 27. 1/3 of 27 is 9. 1/3 of 9 is 3. So for problem number 1, yes, it is geometric, and the common ratio is 1/3. For problem number 2, is it geometric?
No.
No. Okay. So here I'm multiplying by 2, here I'm multiplying by 3, here I'm multiplying by 4. So in order for it to be geometric, it has to be multiplied by a constant number. So number 2 is not geometric. You get all this?
Yes.
Here is the explicit equation of the geometric sequence. Write this down. Alright, so the common ratio of this sequence is 5. A sub 1 is 3. We plugged A sub 1 and R into the formula for an explicit form of a geometric sequence. Here we go. This is the explicit equation of this geometric sequence. Now, I want to make sure that you know that is the first part of this answer. You can't skip that step. Okay? Now what I want to do is I want to check my work, just like I did when we first learned about explicit sequences. I want to just see if the first 2 terms really work with this equation. So I'm going to do A sub 1. So A sub 1 is 3 times 5 to the power of 1 minus 1. And I'm going to simplify that exponent, so 1 minus 1 is 0. And any number to the power of 0 is 1. So I've got 3 times 1, and 3 times 1 is 3. So my A sub 1 is 3. Is my first term 3? Yes, Mrs. Paterno.
Wait, why
First
is
term is 3. Huh?
Why is that 1?
Why is this 1? It's a rule. Any number to the power of 0 is 1.
Oh.
Miss, what is that number?
Which number, honey?
Right there.
This is a 3.
No.
That is a 3 times 1.
At the very top.
Here? Here? Alright, come on up and point to it. Alright, so I'm going to keep going.
After the 5.
After the 5, to the power of 1 minus 1?
Yeah.
Okay. Alright, so now I'm plugging in a 2. I'm going to try and find the second term.
Oh, why is it air conditioner?
So I have 3 times 5 to the power of 2 minus 1. I'm going to simplify that exponent first. So 2 minus 1 is 1. 5 to the power of 1 is 5. And 3 times 5 is 15.
Miss, I can't see.
Then move up here. Look at the screen right in front of you.
I forgot.
So is my second term 15? Look, it is. So it looks as though this equation really does work. All right.
No, don't skip it yet.
So now the second part of the problem was find a sub 7. We're going to find the 7th term. So a sub 7 equals 3 times 5 to the power of 7 minus 1. So it's 3 times 5 to the power of 6. All right, so 5 to the power of 6 is 15,625.
¿Por qué dio 3 en paréntesis abajo?
And multiply by that by 3 is 46,875. Here's the next one. Write this down. All right, so what's the common ratio for this problem?
3.
What's a sub 1?
10.
All right, so my formula is a sub n equals 10 times 3 to the power of n minus 1. That's the explicit equation for this geometric sequence. And then the next thing that I was being asked to do was find a sub 12. So now, a sub 12 is 10 times 3 to the power of 12 minus 1. Of course, 12 minus 1 is 11. 3 to the power of 11. Oh my God. 3 to the power of 11. 177,000. 147. 177,147. And then 10 times that is 177,147,0.
Qué dura.
All right, that's the bookwork. 6 problems. Quiz on this will be Monday.